Hello class, this is a video tutorial on applications of first derivatives. In this video we'll be using the first derivative to solve missing pronumerals. By utilizing properties of functions and their derivatives, it is possible to solve problems of functions with missing coefficients. So let's get straight to an example here. So we have this function x cubed plus ax squared plus bx, and we're being told that it has a local maximum at p 2, and we're being asked to calculate values of a and b. So these missing values a and b here. So let's use the properties that we are given. Let's consider first the point p 2. This means if we substitute 2 into the function, the answer that we get is 2. So let's do exactly that. So f of 2 is equal to, substituting into all the points here, well, 2 cubed is 8 plus 2 squared is 4, so this will give us 4a. 2 times b is 2b. And we're being told when we substitute 2 into this function, the result is 2. So that's equal to 2. Let's divide everything by 2, giving us 4 plus 2a plus b equals 1. 2a plus b is equal to negative 3. b is equal to negative 2a minus 3. So that's as far as we can go with this information. So let's just leave it here for now. Let's now use the next piece of information that we have, a local maximum at this point here. Well, a local maximum means f prime of the value of x is equal to 0. Well, if that were the case, that means if this point is a maximum, if we substitute f prime, actually no, before we continue, we're going to need the second derivative, the first derivative. Let's find f prime of x is equal to, that's 3x squared when we differentiate it. That's plus 2ax plus b. So now we're being told when we substitute 2 into the first derivative, the answer will be 0, because it is a stationary point. So f prime of 2 is equal to, substituting it here, substituting 2 here, that's 4 times 3 is 12, plus 2 times 2 is 4a plus b, there's no value of x here, and we're being told that this is a stationary point. In fact, it's a maximum that is equal to 0. Okay, so letting b become the subject, this will become b is equal to, moving 4 to the other side and 12 to the other side as well, we get negative 4a minus 12. That's as far as we can go with that expression. But now take notes. We have two equations here, both equaling b. Let's let them equal each other. Okay, so let's use another line here. Let's let these two equations equal each other. So negative 2a minus 3 is equal to, this expression here, minus 4a minus 12. Now let's solve for a. This will give us, well, that's 2a, that's plus 4a on both sides. This will give us 2a on the left, plus 3 on both sides. This will give us negative 9 on the right hand side, which gives us a is equal to negative 9 on 2, which is the same as negative 4.5. Solving for a by substituting this into there. Oops. So this will give us b is equal to negative 2 times negative 9 on 2 minus 3. The 2's will cancel out. The negatives will cancel out, giving us 9 minus 3, which equals b is equal to 6. And a is equal to negative 4.5. And just for good measure, let's rewrite our original function with the new values that we know. So, writing this in, f of x is equal to x cubed plus, instead of plus ax, it's going to be minus, because a is now negative 4.5, so negative 4.5x squared, and plus bx, that's going to be plus 6x, because b is equal to 6. So I hope that gave you an insight into using the properties of the function and the first derivative to solve for unknown coefficients. Hope to see you in the next video. Best of luck.